Hi folks, so welcome to your second coast lesson. If you have a module booklet with the green front cover, we're starting on page 4 today. Remember, if you didn't manage to actually pick a copy up, you should have been emailed 2 copies, a scanned version, the quality isn't as good but it's complete, and an electronic version which has all the bits that we write as a department but none of the photocopied extra bits. So the quality's better but it's not a complete version. Between the two of them you have got access to everything. Okay, so having set the scene yesterday, we're going to talk about waves today. I don't know how far we'll get in 15 minutes, but each day we'll just carry on with the module from wherever we left off the day before. Okay, so the first thing that we have to understand about waves is what they are and how they're made. And I think we all know what a wave looks like, but the thing that we need to remind ourselves of before we go any further is that waves are not created equally. So you can see a photograph in the top of that page with a helicopter and a surfer for scale. That wave has a name, it's called Jaws, and it's formed quite frequently off the coast of Hawaii. And then you also have some much smaller, much less scary waves in the bottom. I'm going to send you this PowerPoint. No, I'm not. I'm going to share it with you because it's a massive file, but I am going to make this available to you. And if you want, you can have a look at those YouTube clips. The top one is a video of Jaws, not the film, but the wave. And the bottom one is some very relaxing, gentle waves crashing on a beach, which you might be in quite a lot of need of right now. Waves are not created equally. So what are they? Let's start with that. Well, you have this definition on page 4, but it takes a little bit of understanding. It's kind of like, right, yeah, I can remember that sentence, but let's really focus on what it means. It's a disturbance that travels through the sea. Okay, so something has disturbed the surface of the water, fine, and it then travels, okay. But here's the thing that we need to get our head around, and there's a little diagram on page 5, but I am going to actually show you this YouTube clip because I think it will help you. The wave appears to move, and it does move, but the water doesn't. All the water does is it does a little circle. The energy of the wave moves, the water doesn't. And the best analogy that you can use for this, ladies and gents, is a good old Mexican wave. You may even have participated in one of these. So here is the wave at this part of the stadium, and it's travelling around the stadium. Now the point here is all those individual people are doing is standing up and sitting down or waving their arms up. The energy of the Mexican wave is moving around the stadium. The people are not. Okay? And that, ladies and gents, is exactly what we're trying to get across to you. All right? So waves are disturbances. The water only does a little circle, see the diagram on page 5, but the energy of that wave moves through the water. Where does the energy come from? Okay, you need the diagram at the top of page 4 of the module because the wind creates waves. Now, I don't suggest you try this at home because this is not a period of time where you need to be having accidents and needing to go to hospital. But if you can picture you trying to cool down a hot drink, you can do it with a cold glass of water if you want, but you don't need to cool down a glass of water, so you've probably never done this. If you blow on a drink with the air coming out of your mouth, you create waves in that drink. That's basically the process that's happening in the sea. So the wind is what disturbs the surface of the water, just like you blowing on the cup of tea. And depending on how much kind of energy and other factors that you put into that depends on the size of the wave that you create. And if you get a bit carried away, you can blow water or tea all over everywhere and get told off, probably. Okay, so the wind is what creates the disturbance, which is what a wave is. And because of that, we need to know what aspects of it, what aspects of the wind are going to affect the size of the waves you can get. Why is it possible to get waves like the top photo, but also possible to get waves like the bottom photo? Okay, so the most obvious one is the wind speed. If you were to blow on a hot cup of tea really, 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 really powerfully, you would create massive waves and a massive mess. If you blowed very, very, very gently on that cup of tea, you would create very, very tiny waves. And if you broaden that over the kind of size of the planet, that is the basic principle. The windier it is, the bigger the waves will be created. For the more scientifically minded, that is because more energy is being transferred from the wind into the water. Okay, so the windier it is, the bigger your waves are likely to be. The next one is one of those words from geography that parents and grandparents tend to remember. They always go, oh, Oxbow Lakes and fetch. So fetch is a proper geographical word. Fetch is a distance, okay? So here we are in good old UK. If the wind is blowing from the southwest, so from the Caribbean, the fetch is about, I think it's 2,500 miles. It's really, really, really long. If the wind was blowing from the south, the fetch would be 30, 40 miles. So fetch is a distance. And the basic principle is, if you've got really powerful winds that have been blowing energy into the sea, all of that distance, then you are going to have massive waves because there's been much more time and much more energy transferred into the water. If you have had a fetch of that distance, your waves are never going to be that big. There simply hasn't been enough distance and therefore time for the wind to transfer very much energy into the water. So fetch is something we talk about a lot. How long it's been windy, so let's say we've just had a storm, it's just begun, it's only been windy for like half an hour, there's not going to have been much opportunity for the wind to transfer energy into the water, whereas if it's been windy for the last 12, 14 hours, then of course more of that will have happened. Finally, and this is the one factor that doesn't have anything to do with the wind, it's how deep is the water. If you had water that's about 5 centimetres deep, the maximum possible wave size is not going to be that big because there's not a huge amount that you can do with 5 centimetres of water. If you have 5 metres of water, the potential size of wave increases. So what we say is, if all of those other 3 factors were the same, the wind speed, the fetch and the duration, then shallow water, you would get smaller waves. Deeper water, they would be much bigger. Okay, so water depth has a fundamental part to play, and that's why we're so interested in tides, because tides will affect how much water you've got, which will have a part to play. All right, so just a summative point here. Faster wind speeds, bigger waves, longer fetch, bigger waves, longer time, it's been windy, bigger waves, deeper water, bigger waves. And if you can get your head around the idea that those 4 factors vary, so Hawaii, which has the Jaws wave, Hawaii is a group of islands in the middle of the Pacific Ocean. It's surrounded by deep water. So there's our first thing. We've already got potential for big waves. So if on a day in Hawaii, it's quite windy, well, whichever direction the wind is blowing from, the fetch is going to be long. Okay, so already 2 of our 4 factors are kind of maxed out. We're in really deep water and we've got really long fetch. If they have a storm, hey presto, you're going to get massive waves like Jaws. In the UK, it's a bit more variable. We've already talked about the wind blowing from this direction. The fetch will be quite short, whereas if it's come all the way from the Caribbean, it's going to be much longer. We are an island, so we've got a huge amount of coastline, but it Depends on how windy it is on any particular day and what direction the wind is blowing from. The weather massively controls, the size of your waves, because the weather massively controls 3/4 of those factors. Okay. Here's a bit of a question for you though. You have probably been at the beach at some point in the past and it's been a beautiful day. In fact, today is a good example. I'll teach you in year 2. This is an anticyclone, ladies and gents, high pressure system, no wind, no rain, no cloud, lovely weather. Anyway, on a beautiful day like today, if we were allowed to go out, but let's not talk about that, if we were allowed to go out and you went to the beach, you would probably still see waves. Based on everything I've just told you, that probably doesn't make sense. Okay, bring on the photo of the chocolate Labrador. Okay, what on earth have I put this picture on the screen for you for? Good question. Okay, somewhere on planet Earth there will be a storm. It is not possible for the whole of the planet to have calm, beautiful, non-windy weather. There will be a storm somewhere in the world, okay? When that chocolate Labrador jumps into that swimming pool, it is going to create some waves, and those waves are going to travel until they hit all of the edges of the swimming pool. In the same way, ladies and gents, if you've got a storm, let's say, right down here in the South Atlantic Ocean, that storm is going to create waves because the wind is going to be transferring energy into the water. Those waves will travel until they hit the coastlines around the Atlantic. But crucially, because the storm is down here, as those waves travel, they will lose energy and they will generally get smaller and smaller and smaller, which means, on a beautiful summer's day, no wind to be felt, maybe a gentle breeze is all you get, and it's still waves. They tend to be quite small, they tend to be quite gentle, because they've travelled a hell of a long way to get to your coastline and they've lost energy as they've travelled. But you are still going to get waves hitting all of the coastlines of that ocean, because just like that chocolate lab, the waves are going to be, the waves are going to travel away from that in all directions. Okay, so I think that is probably best paused there for today, because explaining constructive and destructive waves to you is going to take more than the 2 minutes we've got left. So a little bit of an introduction. We'll do a little bit of recapping of that tomorrow before we move on, and then our main topic for tomorrow will be looking at constructive and destructive waves and going on from there. Thanks to those of you that have been sending me marking. Keep the questions coming. Between homeschooling and all the other things that are going on, I will endeavour to reply to you as soon as possible. Stay safe, look after each other, stay sane as well, and contact me if you need to. Bye.